In this session, we will explore how NMDP embarked on a modernization journey. I'm Madhu Busa, a solution architect leader working with nonprofits to enable their mission outcomes. Joining me is my co-presenter, David Rowe, principal architect at NMDP. Today, we both will walk you through NMDP's journey to modernization, showing how embracing cloud-native technologies can lead to life-saving innovations. So we'll start exploring by why modernization is essential and the various pathways available to achieve it. Then, we'll walk you through NMDP's modernization journey, showcasing how we used AWS to modernize their donor matching system. And finally, we'll wrap up with practical steps on how you can begin your own modernization journey and leverage cloud-native solutions to drive innovation. So to innovate, organizations must balance managing technology with building new features. This balance is essential for staying competitive and agile. By modernizing, organizations can shift focus from maintaining legacy systems to drive innovation, increasing the pace of progress. Modernization can also help organizations to get more value out of their investments, reducing costs and improving performance. Finally, modern systems allow organizations to create personalized online experiences that enhance customer satisfaction. I would say modernization is a journey, right? Migration and modernization are essential components of the modernization journey. As you see, this slide illustrates the progression businesses undergo as they shift from on-premises infrastructure to cloud-native solutions. The key inflection point, which is at the center of the graph, is cloud-managed stage, where operational costs begin to decrease while the business agility and innovation accelerate as the companies move their workloads to cloud-native solutions. Modernization also allows businesses to focus their resources on value-added activities instead of managing legacy systems. Again, managing legacy systems has an undifferentiated heavy lifting. This shift not only optimizes costs, but also enables businesses to invest those savings into maximizing innovation and outcomes. It is very important to businesses to look beyond lift and shift strategies. Instead, think modernization is a longer-term journey where both migration and modernization work together to fully unlock the value of your innovation. As I just mentioned, modernization is not just about moving one workload or one system to the cloud. It is optimizing your portfolio to get most value of the cloud. To help you on that, we have developed key modernization pathways. We call that the 7 Rs: rehost, rehost plus, relocate, replatform, refactor, repurchase, and retain. Based on the nature of the workload, one of these pathways become essential. We have seen these strategies consistently deliver impactful results. And out of these 7, we recommend to focus on replatform and refactor. And again, these pathways make it easier to have focused conversations about your goals. And the best part is you can use a combination of it to smoothen your modernization journey as well as suit your business outcomes. So as I said, modernization is not about just migration or a single transformation, right? It's continuous evolving, continuous innovation, adapting to unlock the business value. And again, we are seeing a paradigm shift in how technology and business value intersect. In the past, again, we all relied on physical machines or virtual machines. And again, many of you may already have transitioned to containers or serverless computing. These advancements bring tremendous agility and efficiency. But that's just one part of the evolution. On the data side, we have seen businesses move from being data aware, that is like where you collect the data out of your workloads or systems, to become data informed, where you use the data to inform the decision making. But the real transformation occurs when you move from data-driven approaches, where AI and machine learning can take the center stage and driving key decisions automatically for you. At the center of this intersection, in the middle, right, you see compute and enterprise data is where we see the real value being unlocked. This shift is driving the culture of innovation, allowing you to create AI-powered applications that take full advantage of serverless architectures and deep data insights. I would say this is more than a technical upgrade. It's building out the businesses that can adapt faster, respond to market changes quickly, and innovate continuously. I mean, we all know that tools and technologies are here, but the journey to the modernization is the one that will unlock the full capabilities of this paradigm shift. Now that you have seen why modernization is essential, and then this paradigm shift is essential to unlock the full value of your investments, allow David Rowe to present their modernization journey and then the transformative impact have on their organization.
All right, thank you, Madhu. And good afternoon, everybody. Thank you for taking some time to listen to us today. My name is David Rowe, and I'm a product architect within our organization on the software development teams. And today we're going to just walk you through a bit about the application that we've built and why we built it, and then take you through the modernization journey that we've gone through basically for 20 years, but we won't do all of it. We'll do the last couple of years, which have become very interesting as we move this workload to the cloud. So first, let me introduce NMDP. Every 3 minutes, someone in the US is diagnosed with a life-threatening blood cancer, such as leukemia, for example, you may have heard of. NMDP was set up in 1989 as a global non-profit leader in cell therapy, helping save the lives of these patients with blood cancers and disorders. And we go about that by brokering bone marrow transplants across the planet for anybody that's searching for that cure. Briefly here, I just wanted to talk about why this system and our service is so complicated and has required so much investment from our organization. Basically, we've been built and we've evolved over the last 450 million years to have very different immune systems. So everybody in this room has a very different DNA specific to their own immune system. And the way that genetics works is that gets continually muddled up as your parents create offspring. And we continually move that, mix up that DNA that manages our immune system responses. This is important to us because when we replace your bone marrow, we're actually replacing your immune system. And the difficulty that introduces, it means that there's only a 1 in 20,000 chance that you would actually be a transplant match for a random person in the room next to you. Press it again. If you were unfortunate enough to suffer from one of these blood cancers, you'd go through a fairly extensive journey, only which a part of this is the system that we'll talk about today. But basically, from diagnosis, you may be referred to a transplant center that specializes in this. They would engage with NMDP to start this donor search. So they would take your genetics and post those over to NMDP, and we would start a search for you across approximately 41 million donors that have registered to provide their bone marrow to you completely anonymously and without any benefit to themselves, really. And at that point of actually finding a donor, this is a living donor, right? No one has died. So now we have 2 people that are impacted, whose lives are impacted by this, that we have to manage. There's the patient that's looking forward to receiving good bone marrow, and there's the donor that now has to be helped through this process so that we can actually perform the extraction and get it to transplant. After that, it actually gets even more critical. In order to perform a transplant like this, we actually have to get the patient, that's ourselves if we're sick, into a state that you can receive this bone marrow. And that actually means eradicating your own immune system first. So at the point that we choose to do that, we have to be absolutely sure that our donor is lined up and ready to go. And we have about 48 hours to move that live material to anywhere on the planet to get it to transplant on time. That's performed by actual volunteers from NMDP, so everybody that works at NMDP can volunteer to perform that activity. And I think Ben in the audience here does it on a regular basis. So the application we're talking about today is HapLogic. This is the system that we've implemented that sits in between the research that we participate in, the building of this donor registry across the planet for every donor that we have, and also transplant coordination with the patients. And HapLogic sits in the middle of this, performing that genetic match between every patient that comes in with those 41 million donors to give back clinical results, clinical decision-making results back to the doctors. So how does HapLogic work? It's a fairly standard distributed system that we've built. Every donor that comes in through a registration, we'll take their DNA and have it tested, and that information gets added to our registry. So we're constantly building this registry. In the last year, I believe we added about 300,000 new donors, so that's sort of how fast this is growing. And then we break that registry down into much smaller pieces so that we can do two things. One is that we can search across it much faster, and secondly, we can update it and make changes to it much more efficiently. And all of our implementations have followed this sort of similar model. The patient enters the picture now, and now, depending on how acute their situation is, it could be that we need an answer about finding a donor literally in real time. And that has pushed us to try and build a system where we can execute this match against the 41 million possibilities in somewhere between 15 and 60 seconds. So you're getting near real-time results back for this search. But then more importantly, and unfortunately, not everybody will find a match when they first come to NMDP. So what we do now is we maintain all those searches. If you come to us with that information, we hold that indefinitely. And we continually reverse search against that, all of those patients that are in the system. And if any new matches come up across the world, we can then inform the transplant center immediately that somebody is now available. And that notification comes out within 15 seconds of us receiving that genetic information from the labs. So that's a very important part of what we do. That makes this system very different from traditional searches too. If you imagine Google, for example, you submit a search, but what if Google remembered every search you'd ever made and then told you a better result, a better bit of information had showed up in a month's time? So it's quite a different problem. This is a very busy slide, I apologize for that. But what I want to show here is actually that over the period of time that we've been investing in this platform and improving in it, something radical has happened in the last couple of years. So if you look at the right-hand column, the reason I titled this Jumping the Curve is that suddenly our iterations, so between, we have research, we have IT, technology improving over time, and those have taken 8 years, 6 years, 11 years to actually execute platform changes and massive improvements. If you combine those, in the last 6 years, we've managed to make 3 radical changes to the application. And as we've moved more of this to AWS and cloud-based services, our iteration cycle is now getting down to close to a year. So now we have the ability to innovate and take research in much faster and turn around brand new systems potentially in the pace of about a year. So the topic for today was transition and modernization and how we got there. So let's jump into that topic. We took this whole approach in three separate stages. The first was to refactor our proprietary applications. We had an awful lot of expensive proprietary technology working at this, a lot of Sun servers, if anybody remembers Sun, that actually executed this work originally. We refactored that to the Hadoop open source platform and tried to break that workload into traditional Spark-based Hadoop workloads. The second step we took was to say, okay, well, we've done that. Now we need to rehost that, as much of that workload to the cloud as possible to reduce complexity for ourselves. And then the third part of it was to take what we had now learned from working in the cloud with Hadoop and say, could we do this better? Could we roll our own? Could we actually use AWS native services to do this better? So our first iteration, for anybody that's worked with Hadoop themselves, it worked. But at the end of building this monstrosity, we were managing about 300 servers to run this system across the 8 environments we manage. And that was not really sustainable for a small organization and a non-profit organization such as ours. So this really, even though we were getting the search times and we were getting the immediate business benefit was being achieved, we couldn't afford to do things like HA or DR. We couldn't expand or look forward to expanding the service beyond current business needs without massive investment. So for each of the iterations, I'm doing this quick analysis, and I won't spend too much time on it, but basically, of all the things that we were trying to achieve with this first iteration, really all we managed to do was get off of a proprietary licensing of technologies we were using. Everything else we didn't really achieve, or it was still expensive. So the next hop was to say, well, how can we improve this picture? So instead of actually rewriting anything or replatforming, what we chose to do is take that Hadoop workload and literally lift and shift it to the same technology but on AWS. Now suddenly, those 300 servers didn't bother us anymore. It's all virtualized. It's all managed through the AWS console. And all of the networking and attached storage and everything else that comes with the Hadoop ecosystem suddenly became an awful lot easier to manage. So looking at that iteration for us, things got a little bit better. Okay, so yes, we still got rid of our proprietary licensing restrictions. We had started to reduce hardware costs because we didn't have to refresh our physical hardware that was on-premise. Our infrastructure complexity was greatly simplified, and our internal teams of, I think we only have about 8 people that really run infrastructure meaningfully, were relieved, basically, to get that critical workload lifted away. On the resilience side, now we could do blue-green transitions. The best thing for us that happened on AWS was the limitless capacity. So now, usually when you have an expensive and large system like this, it's very expensive to make that move from one to the other because of the switch-on, switch-off problem. Like, when are you actually brave enough to say, this is now going to support my business workload? But now you're on AWS, you can have these running side by side. You build the new next to the old, and you can continue to build and innovate, take some risks, experiment, because you can have these sat side by side for any period of time until you're ready to say, we're ready to actually transition. And then the transition is literally switching an API to say, go use the new stuff. On the scaling side, though, we still didn't hit the mark. Hadoop still didn't scale elastically. It didn't grow and shrink according to capacity needs. We had dozens of very large clusters because they all had to be sized at that maximum performance picture. And that was hard to do and keep costs under control. And that meant that we didn't actually achieve our total cost of ownership reductions that we were looking for. So this is the fun part. And this was an experiment. And this sort of shows how brave being on AWS can make development teams. So while all of the previous iteration is still running in the background and it was being maintained, the team took all of the code, all of the system, and broke apart everything that was a Spark job or a separate job, and basically created as small as possible processes out of that, sort of a microservices kind of approach to it. And we moved all of that to Lambda. The second thing we did is we took our very large databases that were running on the Hadoop distribution, and we put those on Aurora serverless, which was a very risky proposition because that meant that we were no longer defining our database capacities. We were actually going to take a chance and say, let's let it grow when it needs to grow and shrink when it can shrink, and only use the capacity it needs to at any one time. But this approach took us about 18 months all the way to production. But 6 months of that, it was running in parallel with the previous iteration. And again, because of the limitless capacity, we were able to run this, actually creating exactly the same results, clinical results for every patient that came into the system. And we just ran them side by side every day. And wrote a small Lambda that could compare the results between them. So we were actually getting like real-time feedback about were we getting equivalent results out of the new platform before anybody started talking about a transition plan or were we ready to switch over. This really increased the trust that the business had in IT's ability to deliver, which I think is crucial to everybody. But it also meant that when it came to switching over the system, that took literally minutes, and fail back in case there was any unforeseen situation was also possible, because as long as you kept the previous system running live, it was also maintaining all of these searches, so we could fail back almost instantly. We could never have afforded to do that if it was on-premise hardware or infrastructure that we had to build. It simply would not have happened. So our last scorecard, it's like being at school, our last scorecard looks an awful lot better. We achieved all of the objectives that we had laid out for this transformation. And finally, we were actually getting fully elastic charging, whereby we were only paying for this infrastructure when searches were being executed. So at any period in the day, for example, or even the week where search capacity was much lower, like it is during the night and over the weekends, for example, everything scales down to close to zero. We managed to deliver the system entirely on serverless technologies. So this is Aurora Serverless v2 with Postgres. Everything was Lambda and SQS. So all managed services. Data was on S3. And our total cost of ownership, we actually managed to save almost $1 million a year in our actual infrastructure run costs while improving performance, which is probably why we're here. I try to keep this slide in, and I won't spend too much time on it, but it's good to know for people that are thinking about doing something like this with their own teams. There's a few unexpected things happen along the way. When you use managed services such as Lambda or Aurora, they come with limitations. They come with their prepackaged managed services. It's great. But you don't get to necessarily tune them the way that you would have done if they were your own installed systems. So those restrictions gave us a lot of anxiety, and some risk was perceived from doing this. But that's not what happened. What actually happened is, for our Lambdas, for example, where we have memory constraints, they're limited to 10 gig, we optimized all the data structures in the code. So we were sort of forced to do some real housekeeping and cleaning up and making the application simpler. And for the cold start times, if you don't know what a cold start time is, when you use serverless Lambdas, if they've not been used for a period of time, there's a sort of a warm-up time that can take multiple seconds. That's not a problem if it's a batch process, but if it's serving a real-time process, like an API or a system like ours where we have an expected response times, that could be a problem. But what really happened is we took a look at our Lambdas to see, well, what was taking all this time, and it was frameworks, things like Spring Boot or these expensive and heavy frameworks we were using. We ripped them out and went back to plain old Java. And now the code is cleaner and leaner and tidier. Same thing happened with Aurora, the serverless database. This is a fully scaling managed service. So it basically is not off exactly when you're not using it, but it scales down to very, very low cost, dollars an hour. The things that we were worried about is AWS forces update policies on services like this. So when an upgrade is required, it's going to be applied eventually. A lot of people were very concerned about that. What really happened is our application actually became InfoSec compliant for the first time in its history. And it's retaining that scorecard. So that's an excellent outcome. The next thing was that we were concerned that the database, although it scaled, would it scale fast enough to actually keep our real-time response SLA that we were trying to achieve? And the answer is it did. Aurora Serverless is actually a spectacular service. I have to say, I could not believe how fast it actually expanded its capacity to take care of our workloads. But even to improve that further, the team is now going back and looking at the data structures themselves and doing some good old-fashioned normalizing. Now that we're not Hadoop and on these large monolithic data sets sort of philosophy, we're breaking it back up in sort of the old relational modeling sense. And building that in is actually improving things even further. And the last bit is the unsung hero. Things you get for free if you do this is use of CloudWatch and specifically X-Ray within CloudWatch across all of this delivery. It's hard to actually quantify how important that is to the efficiency of a delivery team. You get all of the observability that you would want while you're coding in real time, and some of it's even visualized. But that same tool set is used across our environments into pre-production and staging, and then into production. So now we have a situation where the tools we use to build the application are the same tools we use to manage the application. So we have a very robust set of monitoring tools and alerting and ways of investigating situations in the application that honestly we'd never have gotten to before, usually due to cost and time overruns and things, but now they all came out of the box for free. So it's not all unicorns and rainbows. We do have some ongoing challenges to address. The first is cost management. In our organization, as a non-profit, and we have a lot of grant funding, a lot of large bulk funding that comes in staged over time. Our investment practices are still very much fixed cost focused and looking for sort of large single investments, and then they're hoping that cost is spent and it goes away. In the new world, obviously, now everything is being charged as we use it. So now we're only getting charged when services are actually being consumed, but you're charged all the time. So you're not buying a system and then having it sat there sort of for free, except for the electricity for 5 years. You actually have to make sure that you budget for this all through the operational year. And that's a shift for our organization that we're working through still at the moment. The second one is an odd one. I called it the free capacity effect. So in an organization like ours, we have a lot of PhDs, a lot of researchers, a lot of IT people with great ideas and things they want to experiment on. And when you build out your own infrastructure on premise, you over-provision. You always buy more than you need. You always buy as much as you're going to need for maybe a year or 2 years or 5 years even. That creates a free capacity situation, right? Actually, in your organization, there's places you can go and run projects that you don't really have to justify. And we've gotten used to that. So you can always sort of go to infrastructure and say, hey, can you find me a server to run a project? And sure, this one's not been used for a while. That's gone away, right? When you build these systems fully on AWS, specifically as serverless, there is no such thing as over-provisioning because you only provision on demand of the workload. But that means now that we have to come up with new and innovative ways really to find that space for people to experiment for themselves. One idea that's come up, I think, is sandboxes. So we're actually setting up, like you can if you're doing an AWS training event, but we're doing that in-house so that you have access to some of the data and the services we use. But you'll get a sandbox if you want to go and experiment rather than just using free capacity. Things like that should work out. And the last hurdle for us is our sort of continuous delivery approach. We have managed to deliver systems and solutions into production using all of the tooling we've got in a continuous delivery or CI/CD approach way. But what we haven't managed to do is test it as it goes through that pipeline adequately. Our testing is still very much monolithic. It's designed to say you've built the application, have you all finished? Everybody say yes, and now you test it to death. And then you're allowed to take it to live. That sort of creates, even though we are delivering solutions much faster than we ever have before, now we're sort of artificially hitting pause every 6 weeks while the organization catches up and we're still sort of in lockstep doing this testing and final delivery. So we still have things to figure out there. We've got to figure out how to break that monolithic testing apart in a way that we can test these components independently, so that if we just change one component of our application, now we can test that and push it all the way to production without worrying about the overall quality of the service. Okay.
Incredible journey. What an incredible journey, David.
Thanks
a lot. Thanks for sharing that. So, as you heard, right, the NMDP's journey and then the impact that it had in their organization, I really want to share one code with you all. I'm sure you might have seen this if you have already attended a reInvent or maybe on AWS blocks. There is no compression algorithm for experience. This code really resonates with what NMDP experienced, right? I mean, again, modernization is not just about technology. It includes the experience and the lessons they gained as part of this process. As they modernize, right, as they modernize their applications, they encounter challenges. I mean, some of the challenges that you have seen, and as well as the lessons learned from them, and then how they overcome those things. Their journey highlights there is no shortcut to innovation. Each phase, whether lift and shift, or refactoring to serverless, whether it's a Lambda or Aurora, was a crucial step, again, in this journey, and then they have significant learnings to optimize their systems and processes. But that's not the end of the story. We'll take a closer look at how these lessons can be applied to you, how you can take this and then enable you to enable your organization to embark on a journey to modernize their workloads or their processes. So let's explore what is a modern application. I'm sure, based on what you heard from David, some of the patterns that you might pick up. The very first key area that we call is like architectural pattern. We want the modern application to be modular with modular services and adapt the domain-driven design. This will help you to be flexible or scalable, and finally, independent management of each service that you create. As you see some of the lessons learned from NMDP, again, they embrace the domain-driven design. Every service they can implement with an optimal data management solution for its specific needs. You want your modern application to be as serverless as possible. This will eliminate undifferentiated heavy lifting and then any overhead you may get out of that one. And then lets you focus on building the code that adds business value and then delivering the outcomes that you're looking. As you heard, right, NMDP adopted serverless in every service that they adapted for the HappyLogic platform. Yeah. The third one, I say, is you want to improve the developer's agility. You want to be simplified and then automate as much as possible and then standardize them. This will help you to iterate faster and then respond quickly to the changing customer needs. You also want to integrate programmatic guardrails. Security becomes a get-go as part of the architecture from the start, helping you to reduce vulnerabilities. I mean, again, as you saw, there's a side effect that NMDP had was improve the security posture as they modernize their applications. And last but not least, you want to decouple and have a purpose-built data management systems. Ensure the data is not shared across every service as its own data management system, which is very specific to the needs. And finally, overall, all this together combined help you to achieve agility and the innovation that you would need to stay competitive. So let's take a look at some of the few next steps that will help you with your modernization journey. If you already have applications running either in containers or you're planning to migrate to containers, AWS offers managed AWS container services such as Fargate, ECS, EKS. This will help eliminate the need to manage complex infrastructure tasks such as orchestration and provisioning that will help you to reduce the overhead. Whereas if you're building applications or new features, we recommend leveraging AWS serverless technologies such as AWS Lambda. Again, serverless takes entirely the need to manage infrastructure, again, allowing you and your teams to focus on writing code to deliver the business value. These solutions provide pathways to modernize no matter where you are, whether you're today with the containers or you're building new features, right? You have one of the options that you can pick and choose. So I want to share a few recommended actions, again, for your modernization journey. Be selective with the apps that you want to modernize. You want to make sure you pick those apps that will amplify the business outcomes that you're looking and help your customer needs. And the second one is our leverage serverless for operational model. This will help you to reduce overhead costs that we just talked about and focus on delivering the value for the organization. And then finally, you don't need to do everything on your own. You can engage AWS and its partners. They bring a wealth of experience to help you with your modernization journey. Again, by taking these steps, you can position your organization to move faster, innovate continuously, and remain competitive in today's ever-changing landscape. So we have a few immediate next steps that we want to share with you all. So first, on the left, you see we have some recommended sessions that are happening later in the week that feature nonprofit customer speakers. As you see, the IMP206 Earthscope Consortium, they're going to talk about how they use AWS for natural disaster earthquake early warning on Wednesday, whereas on Thursday, Compassion International will be talking about how they use AWS for their governance. There is also QR code on the bottom if you want to have a list of recommendations that are geared towards nonprofits. And on the right side, there is a QR code that helps you to get in touch with your account manager. You may be already in touch with them. However, if you heard some things that you want to go deep dive or that you want to get started with, they can always help there. Okay.
All right. Last bit is a call to let's make an impact together. If you scan this QR code on the screen, you can find out more information about NMDP, about donation to the charity, volunteering, or at least advocating for us in social media. We are here at the Impact Lounge tomorrow from, I believe, 10 till 2. Okay, so we'll be manning a table there, and there'll be people you can meet. We'll be down there if you want to come and talk to us. But there's also an opportunity there to register as well. And then the last call is we're hiring. So if you are interested in the kind of technologies that we have been talking about today and in the mission that we've described, please check out the website for NMDP. And we're hiring technical skills across the board, but also in all kinds of areas across the company. So thank you very much for your time. I think next is a bit of time for questions. Oh, is that the same?